Hello. It's our meeting, and I will try my darndest to keep this under 25 minutes, but hold me to that. Tell me if I need to go faster or something. Yeah, I guess I'll just hop right into it. So my name is Aodhan. I just graduated from Florida State a couple months ago with my degree in physics. So now I'm in that kind of weird transition between physics and meteorology, and also computer science, because I'm in this building, and learning quite a lot. So what I'm going to be talking about today is specifically some stuff that I was working on with Sean in the Siphon repository, and in addition, Ward with the netCDF C++ stuff. Just to give you guys a little bit of flavor of where we're going to be going with this, I kind of set the presentation up in like a little bit of a chronology of like what actually happened this summer. So I'll talk about what we intended to do, what we actually did, because that differs a little bit, and then also some fun stuff at the end. So to hop right into it, one of the first things that happened when I arrived at Unidata this summer was I got into a meeting with Sean and Ward, and we talked about the netCDF C++ library. And the netCDF C++ library is right now in a bit of a predicament because it kind of sits behind the C and the Java and the Python libraries in terms of functionality. There are certain things you can do if you're in Python or Java or C that you can't do in the C++ one. But that's a really easy fix. So what we can do is we can just go into the C++ library and add some function wrappers, or hooks sometimes they're called, which is now this graphic is making sense of the cartoon fish hook. So we can make some hooks that go into that C library and pull some functions into the C++. So the people that are obviously benefiting from this are those that are using the C++ library. So I've added also some names of the actual functions that we added in here, but those aren't entirely enlightening for everybody to look at. So I mean, just the point of this is that we're adding extra support to the netCDF C++ stuff so that users that are using C++ and want to use netCDF aren't at a disadvantage. So the second thing that I talked about when I was in that meeting with Ward and Sean was about a previous intern's project. And this previous intern was here about 4 or 5 years ago, and she had come up with this really, really cool idea for plotting hurricanes. And you could basically select a hurricane from a given year from the National Hurricane Center, which is an archive that goes back all the way to the 1850s. You could pick a hurricane and then plot it and throw it up on a map, and it would give you all the models that had been projected and everything. But that was 4 to 5 years ago. Literally everything had broken in there since then. So another task that I was given when I arrived was giving this guy a facelift. So this is a picture of what we actually have now, and I'll just do a demo because why not? Yeah, go live, go bro. All right.
Testing the gods here.
Yeah, really. So we'll see. So here's Barry, and I choose Barry just because he was the hurricane that happened, the one that Max was actually showing, right? That was the same tropical depression thing? Yeah, okay, I know what I'm talking about. See, I'm a meteorologist, please. All right, so you go in here and you pick a bunch of models. So you pick a year, a storm, a bunch of models, and then you get this nice blue marble image. And then, if I can just make this a little bit bigger, we can hit play. And the first thing that we'll probably see is that, did I?
I don't think you got the results from the multiple tracks.
Oh, did I not? No, I think it should. Oh, whoops. Yeah, it might be.
Oh, maybe get storm tracks?
Oh, yeah, you only have one. Don't you have to do it?
Do you need to hit the get storm tracks button?
I think you have to get storm
There
tracks.
goes. Guys, it's like you're teaching me how to use it.
Well, it means it's really intuitive.
Oh, okay, here we go.
There we go.
So these things are plotting. I don't know. Something's happening. It's not having a good day.
I think it's slower than you're wanting to be.
Maybe it's slower on through the
On the Wi-Fi.
yeah.
Welcome to demo space and a presentation.
Yes. So I think that
Okay, people, turn off your phones.
yeah. Right. Give me a minute here. Wait.
Yeah, quit streaming your videos.
Freedom band, please.
Let's see, like another one.
There we go.
It's just no. None of this is.
What's your name? You call it Jay. I got it to work.
If this doesn't work this time,
Look at Julian's computer.
if this doesn't work this time, then we'll just trash it. Oh, I think it actually is working now. But so for right now, we have some models being plotted up. But first, the thing that we're noticing is that the time is ticking through here, right?
Yeah.
So we see that there's going to be differences in pressures and in wind speed, and also the storm type, the classification that we actually have. So finally, some of the plots are coming up. If the models aren't actually if there's no models for like a certain time in the storm's life, then nothing's going to be plotted. So that's why we see at the very end that we actually have these things coming up. So that is the version of the hurricane tracker that we actually have thrown in to the Python gallery now. Hopefully when you guys go and use it, it doesn't go through this whole runtime error thing, but who knows? Okay, so that was the hurricane tracker that we were working on. And yeah, so we had gone back and we fixed this previous intern's hurricane tracker. And this was really cool because it was like an awesome data projection project in the sense that we were able to like visualize these things that are obviously really pertinent to scientists and to users. But for a more Unidata like centric project, it would be instead of making this pre-cut little products that we're giving to the end users, it would be to enable them to go and get their own data, the same data that I used to make this hurricane tracker, and let that be widely available so that pretty much anybody could go and do their own analysis. So that was the next thing that I started working on, which was adding the National Hurricane Center to the Siphon repository. So Siphon, as you guys know, is obviously something that goes and gets data off of threads. But it also has this rogue part of it. And this other part of Siphon goes in and looks at other like online web servers and takes data from that. So we have the National Buoy Data Center, and let me see, what was the other one that's on there? Wyoming Upper Air, there's another one. Iowa State is a third, yes. And what we've done is we've added in the National Hurricane Center onto that. So now we have archival data going back to the 1850s that's accessible through Siphon. So that was awesome. So that was a really cool project. So we're enabling the end users to have like a ton more options to do with this data. And it's really easy to pull it in from Siphon. In addition, while I was doing that, I also saw there was a bit of a need to add the Storm Prediction Center. And the reason for that was because while I was looking on the user feedback, there on the GitHub report page, or is that what it's called, problems or issues page, someone had said that they would like to have daily storm reports be put on there. So I worked on actually also putting the Storm Prediction Center into Siphon as well. So now both of these other online servers are available through Siphon. So it's just giving people a ton more data that they can go and plot with and have fun with. But with the National Hurricane Center, we started off with this end product, and then we brought it and made it much broader so that everybody could use it, right? For the Storm Prediction Center, that was something that I had intended initially, that we were going to make this like this broad idea that anybody could go in and get data and use it for whatever they wanted to. But it's also helpful to show people exactly like how to use these things and why it's important to have Storm Prediction Center data in the first place. So we also wanted to make a GUI for that. And that's what I'm going to try and demo again. But yeah, right? Maybe I could just, cut my losses here, but I'm going to try it anyway. So here,
you got this.
Yeah, let's hope so. So here's the Storm Prediction Center GUI. So we go in, we select a date, and then we pick a bunch of storms that we want. We can plot these, and then we can animate them and see how they iterate throughout the day. While I was doing this was actually Max's idea, was to add in like a comment ticker here, which was an awesome idea because it like really highlights a different type of data that is included in the Storm Prediction Center and the storm reports than you usually see. Because usually what you have is like lat longs and you're talking about either tornadoes or hail or whatever. But Max had the idea to add in comments, which is actually hilarious too, because sometimes you'll see that people are adding in like comments into the Storm Prediction Center that are like based on Facebook statuses and stuff. So this is a fun, different way to kind of interact with this data. So let me just talk a little bit more about these actual two data sets and what the National Hurricane Center and Storm Prediction Center actually have in them. So National Hurricane Center, we have data from 1850s, which I already said. We're talking about speeds, pressures, where these storms actually are, and the times that they're actually happening. And also, obviously, all of the models that go along with any of these storms. For the Storm Prediction Center, we're talking about a very, very different data set. There we have tornadoes, hail, and wind events. And those also have lat longs associated with them, and they're compiled into like daily pages, basically, where they're put onto the internet with 1 day's worth of data for the tornado, hail, and wind. So both of these projects were super, super fun for someone who didn't actually know a ton about meteorology, because it was focused much more on data accessibility and also data visualization. So those were a lot of fun for me, and I kind of like started getting more into this, and I have to say that I really, really appreciated my 2 mentors for this specific reason, that they gave me so much freedom to kind of like experiment with other ideas that I may have had about some cool stuff that I wanted to learn about that wasn't necessarily fitting into the category of Siphon or of netCDF. So one of the things that that I'm more personally interested in is climate. And I'm kind of making that transition into atmospheric science to specifically study climate. So I wanted to make some type of like working climate visualization as well. So, or a climate change visualization, for better words. So I was working on this for a couple weeks, and this was actually like a JavaScript project, which was super cool because I had to learn how to do JavaScript. And it shows temperature anomalies over the Earth for 100 years. So it's a century of temperature anomalies. And we can click through over here on the left, and we're seeing that the spikes change, right? And also the color of the spikes change. So blue means that it's colder than an average from 1950 to 1980. And those more yellow and red ones are showing that we have higher temperatures. And just as all of the other doomsday predictions have said, that by the time we get to the 2010s, we're seeing some really, really, really crazy temperature anomalies compared to that average. So this was a fun project because it was obviously something that like I worked on, and I actually just found out that this was accepted as a Google Chrome experiment. So it's kind of cool that we have like our fingers in that. So we're uploaded onto the experiment website. What was the other thing? Oh, okay, yes. So this is a really cool data set, and it's like fun, but it's super easy to visualize, right? And like everybody knows what a temperature anomaly is. But that is not the case for a lot of stuff in meteorology. If you guys talk to meteorologists and are meteorologists, you find that they're super, super into pressure and like pressure contours, right? And that was something that I was, they're like obsessed with it. So that was something that I also wanted to go about visualizing and trying to figure out how do we wrap our heads around this idea of geopotential height. So geopotential height is related to pressure because we can select a certain pressure layer in the atmosphere, and then we can figure out what are the geopotential heights relative to that layer at any point over the surface of the Earth. So this is obviously like a really, really rough prototype, so no judgment, right? But I will show you guys what I have working here. So this is a working version of the geopotential height manifold thing, which I'm calling it, right? So this is showing the Earth, and then we have this web of weird colors that are everywhere around here. These are the web's height and relative distance above the Earth's surface is showing how high the geopotential height is relative to the other spots on the Earth's surface. The colors are showing wind speed. So up there, the thing that's highlighted in the yellow is just some date of data that I had pulled in, right? So that's December 1st of 2018. So that's like a really, really standard day for the Northern Hemisphere jet stream stuff. So if we move this around, you guys can kind of see it. It's kind of hard to see. I'm still working on this whole color map thing, which is harder than I expected. But we see that the southern pole and also the northern pole, we have really high wind speeds that are constricted like to those regions, right? So that's obviously what we're seeing. That's the jet stream. That's what we expected to see. But I chose this day because if you guys will recall, back in January of this year, we had this like crazy polar vortex thing, and everybody was talking about it and was showing, or was saying how ridiculously bad, how cold the temperatures were. So I wanted to go about visualizing one of those like large scale dynamics things, but doing it through JavaScript and something like this. So if we look at like the continental United States and Alaska over here, right? We're seeing the top is pretty planar. Obviously, there's a lot of divots and everything that's around here, and this is for the date of December 1st. But when we change this to January 25th, we have a very different story. So I don't know if you guys just saw that, but this what I'm calling it is the Coke bottle, right? So we see that over over the west coast of the United States, there's this huge ridge that's popping up. And that means that the jet stream over here, where the trough happens, is right over the continental United States. You see this huge swooping down motion of the jet stream over the US, and also the speeds pick up. And like, the reason I call it the Coke bottle is because like under, you know when you like flip a Coke bottle under, and then there's like those weird feet thing that are on it? That's kind of like what this pressure contour to me kind of looks like. So yeah, and then you can also see how just bad, how far down the jet stream was during this time. Like if you look at how these wind speeds over here are much, much lower than they were in December. As you can see, yeah, just that contrast between the two. But again, this is still like super rough.
What's the data set usually using GFS?
Yes, so yeah, that's another thing. The cool thing about this is coming out with threads. So there's another Unidata plug. And yes, I think that's about
So it's
it.
GFS analysis, is that what this is?
GFS analysis that we're taking for those dates, and they're both taken at like 12 UTC. So what? Yeah, and I think that is about it. But before I end, I just wanted to say thank you to Sean and Board because they let me do so much stuff, and that was super cool, and I really appreciate it. And to Jessica and Max because they taught me an unreal amount about meteorology. And yeah.
Are you going to show
That's about
people
it.
the brain?
What?
Are you going to show people the brain?
So, okay, so yeah, so that was actually, the brain was the first thing, it was the first run through of this, which Jessica saw. But actually what I realized, I only figured this out like 2 days ago, that I had been plotting everything wrong. So this was very much of a crunch time project because I only figured out that what I was doing and what I was showing everybody was like entirely wrong data. So let's cross your fingers that this is right. But yeah, so any
It's
questions?
reasonable.
It looks right.
It looks reasonable.
But anyway, questions, whatever, about anything, about this one or the other guy?
That's where it's
This looks great.
And on these, as we've been talking,
Yes.
all of this data was pre-processed. When you render the HTML here, you're not doing any data crunching.
No.
Whereas your other one, that was kind of a live plot.
Right. And
This requires quite a bit of pre-processing.
yes, it does. And one of the things is obviously like, yeah, in a ton of different ways too, because like one of the most simple things is like this is plotting wind speed, but wind speed isn't something that's given by the GFS. It gives you, UV, so you got to go and do some back work before you can even get to the point where you even have the right data to throw on here. Yeah. Yes, absolutely.
What's the framework you're using here, and how is it getting the data from scratch?
So it's actually, so it's not pulling the data directly, right? It was something that I had to do. I had to go and pull that off. So this is all running in JavaScript. It's using a 3D visualization package called PhiloGL. The other guy is using another one that's called 3JS. So they're not the big guys, the D3 or anything. These are actually using different ones. What was the rest of the question? Sorry, go ahead.
How do you get the data in?
So yeah, so we pull the data. So I literally go and I find the date that I want to take it for, and I download that. Then I put this in. Then I have to go and get this wind speed and everything by using X-arrays and Python and whatever. And then once all that data is done, then I can throw it onto here. So there's a lot of middle steps before I can get to the point where I'm just throwing this in. So we're not at the point where we can just be like, oh, we have data from GFS. Let's just throw it onto this contour viewer, right? So right now, the only thing that this is really good for is being like, hey, I have a really specific case study. What does that look like on a pressure contour?
Did you share this with Jessica? And Jessica, did you try to do this in the IDV and just to compare the results?
No, we didn't talk about it at all.
That'd be an interesting.
She was giving me
You take
feedback.
500 geopotential heights from the IDV from the same timestamp,
Mm-hmm.
throw it in the IDV, and then you can make sure that your calculations are correct. Or
Yeah, and that actually is working.
because the IDV will contour, and you can also even shade it with wind speed.
Or I could do you could actually do a contour surface, and I could do a contour surface of pressure. It would be opaque.
Yeah, well, you can do the 500 millibar so you can make sure that
Yeah.
the things are handling the way that he expected them
Yes,
to be.
exactly. The benefit of these things, though, are that they can just run in a website. You know what I
Right,
mean?
oh yeah, I'm not saying that, that
Yeah,
you should
no,
but just for
absolutely.
comparison.
I gotcha. For sake of validity,
Yeah, for
yes.
sanity,
Yes,
sanity check.
yes.
Now, Howard's working on something in Threads, the data server, that would be able to respond back to a service or something like this and feed it data directly.
That'd be nice.
And what
Just
that
like
would enable
Manifold
us to
threads?
do is have a new viewer in TDS like Godiva, but 3D.
A web 3D viewer from threads, that would be sweet.
This globe is rendered by some code out of Google called Globe.js. It's just a JavaScript.
This one isn't using this one. That guy, that's the other
Oh,
one.
that's the
This
other
guy,
one.
That's
yes.
that one.
Yeah.
And I don't know, that honestly might prove to be a problem though. Well, we can talk about that later, Howard, but yeah. Anyway, any other questions?
It's a fabulous prototype for data visualization.
Yeah, that's great.
Yeah.
That's great.
Oh, that's really great stuff, Ed.
And so what does that mean when
Yeah,
you say
my
this
plug.
is a Chrome experiment? What exactly does that mean?
It just means that you like submitted into a pool, there's like a bunch of people that do these projects, and then they just ask, and Google features like 3, and then we're on there, so.
So it's like a public gallery.
Yeah, so it's a public gallery for Google Chrome experiments, so you can look it up, and we're on there.
It looks really good.
We need a powered by Unidata badge we can put on there.
Oh, like the one in Max has.